Welcome, everybody. My name is Eden Yesh. I'm one of the owners at Kootenay Solar, and we're doing this. We've done these presentations in the past in person, so we're going to try to do this over Zoom today. I'm going to be speaking like an auctioneer for the first 20 to 30 minutes, and what I would ask you to do, just so we can respect everybody's time, is throw your questions in the chat room, and we'll have 30 minutes at the end to discuss anything. Test 1 2. Can you hear me now? Test. Cool. Thank you. And I thought after 10 months of doing Zoom, we would have this figured out now. Again, I've thrown the agenda in the chat room, and I'll throw it in there one more time just so the folks that just joined the call have it. My name's Eden Yesh. I'm one of the owners at Kootenay Solar. And what I was saying on mute for the first minute was that I'm going to talk like an auctioneer for the first 20 minutes. And if you have questions, just throw them in the chat room so we can respect everybody's time if they need to get rolling at that half-hour mark on their lunch break. And yeah, we'll answer questions at the end. I'm going to go through quite a lot of information and throw quite a lot at you. 1,000 bits per second. There's going to be a little bit for everybody in here of some kind of takeaway, and feel free to reach out after by email if you have any additional questions. You might hear a lot of dinging. That's new people coming in the weight room, so just bear with me there too. All right. Again, my name is Eden Yesh. I wear many different hats. I'm one of the Community Economic Development Manager and one of the senior managers at Kootenay Employment Services. I sit on the BC Cooperative Association Board of Directors. I chair the BC Community Impact Investment Coalition, and I'm also owner at Kootenay Solar. So lots of different hats, but the main theme that winds them all together is that I really focus my career on building local resilient economies, whether that's setting up investment co-ops, whether that's doing a clean energy transition and trying to reduce carbon emissions in the Kootenays. I used to run local food business, bringing fruits and veggies, fresh fruits and veggies up from Creston to Invermere. Now with decentralized electricity production, that's just a great common theme in my life, is trying to build local resilient economies. So today we're going to talk again about a lot of stuff: how solar panels work, the different types of solar arrays, ways to mount solar panels on different roof structures or ground mounts, the history of the solar sector and electricity rates in BC. Talk about solar irradiance, how much usable solar irradiation there is in the Kootenays to produce electricity. Then I want to talk about a very big picture, what's happening globally with climate change and how does decentralized energy production tie into that, rooftop solar. And then we'll talk about what our process here is at Kootenay Solar for designing systems and then installing them. So, right to the basics, solar panels are made up of many different layers. You've got your frame, you've got tempered glass on top to protect from heavy snow load, hail. Then you've got your encapsulant. Your solar cells are made out of silicon and boron that generates the electricity. And then you've got a junction box at the back and wires that come out that tie into each other. All solar panels are made very similarly. There's different cords, MC4, T4 cables that come out the back, but they're all very universal. Sorry, I'm just adding a couple more people into the room. Basically, when a photon comes down from the light, it bumps atomic type of boron out of the top layer, and as those atoms knock through, there becomes dead space. I'm not the electrical engineer to talk about this, but that's what generates the flow of electrons. Is very basically when the sun's photons come down, it's knocking out pieces within the silicon boron substrate levels and creating positive and negative space, and the electrons start flowing, and those electrons flow out the wires and create direct current from the back of your panel. So direct current is produced by solar panels in your house. Basically all of the appliances we use in Canada are alternating current. So there are two different sizes of solar panels out there. There's 72 cell and there's 60 cell. Really depending on your roof structure or your ground mount, we're going to look at how many we can fit on. So we'll fit it to your budget, or we'll fit it to the amount of size of your roof. If you want to just cover your entire roof with solar panels, you might be able to squeeze on one more row of 60 cell panels as opposed to 2 rows of 72 cell panels. So really, when we do our software and our design of solar on your roof, that's what we're looking at, is your maximum allowable roof space and your budget, and that'll determine whether you're using a 72 cell or a 60 cell. The efficiencies are the same. It's just you have more solar cells in a 72 cell than you do in a 60 cell. So it's not that one panel, a 335 watt, isn't as efficient as a 400 watt panel. It's just you've got more solar cells and it's a larger, wider, and taller cell. On average, a 60 cell solar panel is going to be about 5.5 feet tall by 3.25 feet wide. And a 72 cell panel, which these are getting bigger every year, but they're about 6.5 feet tall by 3.25 feet wide. Talking about solar radiation, the usable amount of solar that we have to generate electricity, you'll see in the southeastern corner of BC and the Kootenays, we're actually very high. In the Kootenay region, it's about 1,100 to 1,200 kilowatt hours per year per kilowatt that you can generate. Sorry, about 1,200 to 1,300. That's unshaded. And what that means is that the average house in BC, this information is a bit skewed because the average house is in the Lower Mainland, uses about 10 to 12,000 kilowatt hours per year of electricity. So if you did if it was 1,200 kilowatt hours per kilowatt per year, a 10 kilowatt system, which is an average residential install, would offset the entire 12,000 kilowatt hours per year in BC. And there's a lot of different factors that we won't dive into today on this call. If you're burning propane or natural gas, or if you're all electric, but your energy and electricity consumption is based on your energy loads, and that's based on an annual kilowatt hours that you use in electricity. So we'll size to your budget, we'll size to the maximum allowable roof space or ground space if you want ground mount, and we'll also size to the maximum kilowatt hours per year that you use based on previous energy bills. The reason being is that the BC Utilities Commission just changed. BC Hydro is pushing for a change in the net metering program, and there was a definition in that act that said if you have surplus energy at the end of the year with net metering, because you're credited, if you produce more solar electricity than your house uses, you would have surplus energy credits. And those surplus energy credits used to be paid out at 9.99 cents per kilowatt hour. So what people were doing was oversizing solar arrays and dumping extra electricity into the grid, and that wasn't the purpose of the net metering program in the onset. So they said, will continue to pay out surplus energy, but at mid-C prices, which their energy trading arm, the mid-C price is 3.99 cents. So surplus energy, if you do generate more electricity through a grid tie system, you'll still get paid out surplus energy, but it's not economical anymore for people to throw a massive solar array in their backyard and make money from BC Hydro dumping more electricity onto the grid. Long story short, the point of the net metering program is to offset your electricity bills in your own consumption in your own property. So again, this map just shows that we've got a very high solar irradiance. Germany and California, they're at about 900 to 1,000 kilowatt hours per year per kilowatt. And those are the top two jurisdictions globally that have the most solar initiatives and installations. So in the Kootenays, we actually have more ability to generate electricity than California and Germany does. Again, off the back of your solar panels, it's direct current energy. And we need to turn it into alternating current energy for your appliances, your lights, your fridges, your stove, your washer, your dryer, your baseboard heaters, all use alternating current. And to do that, you use an inverter. There's many different types of inverters. There's microinverters and there's string inverters. This will give you a very basic overview of what they do. Over the last 50 years of the solar industry growth, a lot has been pushed down to the bottom side, microinverters. The beginning of the solar industry, it was all string inverters. So if you think that a tree shades one panel, all of the panels go down to the weakest link on a string inverter. So what they did was string inverters with power optimizers. This middle section is that if that tree shades out one panel, the entire array is not going to go down in efficiency. It only affects that one string. But then you still have a large inverter with one central point of failure that's usually attached in your garage or next to your control panel. And then you've got power optimizers on the roof. What we use most often, unless it's a ground mount with no shading, is microinverters. String inverters are taking direct current off the roof. It's higher voltage coming off of your roof into your house. Microinverters bring the voltage down, safer, and turn it to alternating current right on the back of the panel. So instead of having one large inverter in your garage or your shop, you have microinverters behind each panel or behind every second or fourth panel. So it allows every panel to be optimized so that shading doesn't affect your entire array, and it creates alternating current right on the roof, which is safer as well. And that's the products we tend to use, unless we're doing a string inverter system, which is slightly better cost, but only if there's no shading involved, like it's sitting out in the field on a ground mount. So a couple different types of, so we've talked about solar panels, we've talked about the type of electricity that comes off solar panels and that we need to switch it. Now we've talked about the inverters that switch it to alternating current, whether it's a string inverter in your house, in your control panel, or microinverters on the roof. The different types of solar systems that we install, there's grid tie, there's grid tie with battery backup, and then there's complete island off-grid system. There's no electricity lines coming in. So what happens with grid tie systems is that your solar panels create direct current, switches to alternating current, and your house uses that energy consumption. If you're away during the day and the sun's shining and you're producing more electricity than your house is consuming at any given time, the net metering program with BC Hydro or Nelson Hydro or Fortis BC allows you to put that excess energy into the grid, and then when you need it at night, you pull it back. And on the side of your building, you're going to have a meter, a utility meter, Whether you're in Nelson, we work with Nelson Hydro and they'll come and swap out those utility meters for net metering, which basically just tracks, the meter can spin both ways. FortisBC and BC Hydro have already done this. Most houses out there already have smart meters. But basically, if you're producing excess energy, the meter spins backwards and creates credits for you that you can then use at nighttime. At the end of an annual cycle, if you have surplus credits because you produced more, you'll be paid out at 3.99 cents per kilowatt hour on those credits. So that's the way grid tie works, and anyone in the solar industry will strongly recommend that you do grid tie system if you're near power lines or if you're already connected to power lines. The cost of batteries and all of the products that go into them now are not cost effective unless you have to run 500 meters of power line up to a new property. Then the economics make sense to look at off-grid systems. Net metering with battery backup is another option. So we've got some customers in Caslow and the Cusp area and the West Kootenays where they have pretty significant power outages, and they're running diesel or propane generators for 1, 2, 3 days at a time. So that's a lot of carbon emissions. They're looking at grid tie systems, but when the grid goes down for 12, 24, 48 hours, they'll have a battery bank with a hybrid inverter. So the hybrid inverter allows them to use it in their house, do the net metering, but it also connects to a battery bank for basically a critical load panel. You just want to make sure that you've got heat or a sump pump or some of those critical loads, a couple different lights and outlets, that if the grid goes down on a ongoing basis pretty consistently, you create a critical load panel that those battery banks can feed. Off-grid system, you're basically no wires are coming into your property, you've got no utility. Your solar panels will generate direct current, and you've got a charge controller that feeds your battery bank so it doesn't overcharge it. And then when your appliances are being used, the battery bank is going to suck through the inverter and turn it to alternating current. Because batteries store direct current, your inverter in your house, your inverter needs to switch to alternating current for your house. And then you've also got auto generator starts, that if your battery bank in the wintertime is running low or the sun's not shining for any reason, if the battery bank gets too low, it signals the propane or diesel generator to auto start to feed the inverter and put power to your appliances. So we can also do that. It's more of a design process for an off-grid system, but we're happy to do that as well. Many different ways to install solar. If you want to build a new deck, think about if it's facing south, you can generate electricity on that new structure. There's ground mount options if you don't have enough roof space and you want to offset more than your roof can hold, similar to this one. If you've got multiple dormers and pitches on your roof and you've got a high electricity bill, but you've got a field out in the backyard, we just did a installation that is about 176 feet away from the house in a field. So ground mount is an option, carports, or rooftop. So the easiest and the most cost effective is a flush mount on your existing roof on the existing pitch of your roof. That's the best economics for solar right now with a grid tie system. And again, there's also many different types of roofs. You've got asphalt roofs, you've got standing seam metal roofs, you've got different mounts on the side of your building, awning mounts, or you might have a commercial building where we do a cement ballast roof where there's no penetration into the roof. So if you've got a commercial facility, you do a ballast system, you put cement blocks down, and all of that is engineered to just sit on the roof rather than penetrate into a flat roof. All of these are engineered products. We use almost explicitly Canadian domestically made products. And we do have options to everything on the market with our distributors. But we like to use kinetic racking and Canadian solar for both racking and panels. Talking about solar trends and electricity trends, we're here in 2020 and rates are at about 12 cents to 14 cents. Average is 12 cents per kilowatt hour that we're paying with BC Hydro right now, or Nelson Hydro or FortisBC. These graphs in our solar proposals that we provide to you free of charge, it takes in a 4% average increase annually. That's on the last 10 years of the Consumer Price Index with electricity. If you look at the 20-year history of Consumer Price Index, it's risen about 2.5%. But if you look at the 10-year actual rise of electricity rates and add in any Site C overruns, that that is billions of dollars in overruns already, and that's a Crown Corporation project. Taxpayers are eventually going to pay for that, so it could be anywhere from 4 to 6% increases annually for electricity rates. When you look at what the federal government just did, where they did a raise from $30 per gigajoule of carbon to $170 per gigajoule of carbon by the end of the decade, that's the carbon tax. They're increasing the carbon tax over 2020s till 2030 very significantly, sixfold. So if you're burning propane or you're burning natural gas to heat your homes, expect that cost of energy and heating and cooling to go up significantly this decade. And the cost of electricity continues to climb. So what's happened is that in the last 5 years or so, solar has become more cost effective. It's become cheaper to generate your own electricity on your roof than to buy from the utilities company. Not in the future, right now. That threshold took place about 5 years ago, which is why you're not seeing, like, the first 30 years of early adopters was, they're installing for environmental purposes, not for economical purposes. Now it's a pure investment decision. Is you can make anywhere from 4 to 8% annual return on your investment by just generating your own electricity. That's what these free estimates will show you over the lifetime of the system, 30 years, 25 years under warranty. You're going to generate this amount of electricity and save this amount from BC Hydro, FortisBC, or Nelson Hydro. And again, what's happening in the industry, actually, if I just go back one slide, what I'd like to show you is that every solar array is, they're under warranty. The microinverters and the panels are under power output warranties for 25 years, and there's no moving parts. This isn't solar hot water systems with glycol. This is solar PV, which is just slap it up there and it stays there. In 25 years, from 2020 to 2045, if rates increase 4% annually per year, you're looking at mid-30, high 30 cents per kilowatt hour. If it increases 6% with Site C overruns, you're looking at 50 to 60 cents. The reason you're seeing California and some of the US states adopting solar like crazy is because they're already up there at peak energy demands and electricity prices, which solar becomes so much more feasible to install in very quick payback periods. California this year, or last year, sorry, mandated that all new builds in California must have solar installed on them. The next signal that they're doing is that every build in California must have solar and storage. So this is a global trend. It's not just in BC. BC is very behind the ball when it comes to supporting and incentivizing solar. We've got BC Hydro, which is a Crown Corporation that basically has a monopoly on the electricity distribution and sales in BC. So decentralized energy, where you're producing your own electricity on your roof, is a competitor for market share for them. So you're not going to see many incentives from BC Hydro or the BC government for solar. And again, with the federal government, their MO and their signal is that they're increasing carbon tax. So as opposed to what the United States did, where for the past 15 years they had a 30% tax credit that said, if you install solar, the federal government will pay 30% of that cost. Our federal government's not doing that. what they're doing is, instead of giving money out in tax rebates, they're creating a new carbon tax and increasing that significantly. So they're filling their federal budget with a new tax as opposed to giving tax out. And with all of that new income coming in from carbon tax, they will eventually start doing more incentives to do research and development and move that into the renewable energy transition. But for those folks on the call that are waiting for a tax credit program like the United States, it would have happened by now. So that's what's happening with electricity trends. Carbon tax credits and propane and natural gas are also going to increase this decade. And what you've seen since the 70s is a 300 times drop in prices in solar. So in the 70s, if you were to install solar, it was at $76 per watt for a solar panel. And now in an industrial setting, you can get solar panels for 25 cents per watt. It's basically rock bottom prices now. You're not going to start seeing cheaper solar panels. Every year there's increments in efficiency. Where you're starting to see cost savings is solar panel companies are buying out microinverter companies, and they're starting to manufacture solar panels with microinverters attached. So you're saving on labor costs. Labor is about 20% of the price of solar. 70 to 80% of the price of your solar install is cost of goods sold. So the cost of goods, as you see here, has come down basically to rock bottom. So the only other margins for solar installations are to make more efficient solar installs. And that's manufacturing the panels and the inverters together. So you're just laying one piece. Oh, I see somebody can draw on the slides. I didn't know that. Okay, so that's what's happening with solar prices and the price of solar itself. But we're also seeing a paradigm shift. For the first time in history of our civilization on this planet, we can produce our own energy. Whereas, the last 200 years, it's been industrial, centralized command, control, distribution, and sales. We can't just throw an oil well or a propane, generate propane oil and create our own fuels for our own electric energy in our backyard. Now we can create our own electricity, which heats and cools our homes and runs our appliance right on top of our roof. I don't know how much more I can stress the significance of this, is that the entire paradigm of energy, which our world has been built around, is now decentralized at an economic scale. So you're going to see this decade with technology, with electric vehicles, with decentralized energy, and with apps like PlugShare for charging EVs, battery storage, you're going to start to see the decentralization of the energy, which is the biggest industry in the globe. So we're already seeing it, but microgrids are coming to a forefront where you're not generating massive electricity at a hydro reservoir and having to build massive Site C dams and billions of dollars of overrun and flooding out good ALR land to generate electricity to then transmit all the way back down to the lower mainland. You can start doing decentralized energy. You can do battery storage. You can do wind energy. You can there's so much more efficiencies economically with microgrids than there is in the mega project, distribute, and own the sales and distribution. So it's going to be an interesting decade ahead as we watch that paradigm start to crumble. Now to this is the last couple slides here, but to some pretty serious information. This is what's happened since 1751, start of the Industrial Revolution, and the amount of carbon emissions that we've pumped into the air ourselves as human beings. And if you look at the last 10,000 years, at the exact same moment in time, This is the carbon parts per million units in the air. So this isn't like when you look at the ice ages. I'm sure we're all drinking the same Kool-Aid, that we understand that climate change and global warming is real. Anybody on this call? If not, you can just get off the call now. But at the same time that we started pumping in our own fossil fuels into the air, which create carbon emissions, you saw the parts per million of carbon dioxide in the atmosphere just skyrocket. And the entire global governments, through the Paris Climate Accord, it started in Japan through the Kyoto Protocol in the 90s, but they were saying we need to get our carbon emissions under control. It's been 20 years of talking and talking and talking and talking, and then I think in 2015 in Paris, all of the countries in the world decided to come to a common goal and common targets for carbon reduction. Since 2015, if you think of the last 5 years, what's been on the agenda of every intergovernment panel, G7 countries? Climate change, climate change, climate change. We're in, even at Davos, the World Economic Forum, climate change was the top 5 agenda points at that. The Bank of England, the European Union, pension funds, everybody's divesting of fossil fuels. They see the writing on the wall. Fossil fuels are becoming a stranded asset. And you're seeing people flee that into renewables because of the economics now. And because we need to get a real good grasp on how much carbon we're putting into the air. Because climate change is real and we're feeling the effects here. 8 of the hottest recorded years in history were through the 2010s. And as somebody that lives in the Kootenays with a whole bunch of timber surrounding us, that's a scary thought. You're starting to see unprecedented things happening so consistently. Even floods and winter storms, wind storms that are taking out power outages or creating power outages. The old paradigm of centralized energy and distributing is a volatile and vulnerable system to climate change. Decentralized energy production with microgrids or local production is way more resilient when it comes to electricity and energy needs as well. And it's clean. Solar is the cleanest source of power besides nuclear, and we all know nuclear is not taking off anytime soon, out there. The lowest greenhouse gas emissions over the entire life cycle. So when you look at the mining, the shipping, the manufacturing, and the installation, and then the lifespan of the system, solar is at rock bottom for greenhouse gas emissions. And that's what's happening right now, is we really need to get a check on our carbon emissions. The other thing I want to talk about, this just shows you since 1995 up till 2050 how big of a market share solar is taking now. Even in 2020, we're still at the early adopter stage, but by 2050, it's going to be renewables combined are going to be 73% of the energy grid globally. British Columbia is a leader in carbon emission targets in Canada. But what we say and what we do are 2 different things. We have in our Clean BC Act, very in line with the Paris Climate Accord, we have targets based on 2007 greenhouse gas parts per million in the air and greenhouse gas emissions. And if you look, we have to reduce, I think, by 30% or something like that. And anyways, where we are today is way above any of the targets mentioned in those plans. And there's a lot of talk happening. So to take action at the individual level, solar and an electric vehicle and swapping out to electrification of your fuel sources and heating and insulating your home properly, that makes a huge statement. Um, Electricity and energy are not one and the same in BC. Yes, we produce 95% clean electricity in BC, 90 or 95% clean electricity, but it's only about 30% of our energy sources. We still drive around in internal combustion engines, and we still heat with propane and natural gas. And, you know, we have to electrify that entire piece, but with clean electricity if we're to reach those carbon reduction targets that are critical to our environment and our planet. And in the Clean BC plan, you'll start to see in this next decade mandates for more electric vehicles and mandates for more fuel switching to electricity. So if you think back to those trends and how much BC Hydro and the utilities companies are going to have to charge for electricity for that old centralized and distributed, or a levelized cost of solar, you're going to start to see, as you're required to buy an electric vehicle and charge that battery with electricity and run your entire house off electricity in the next 10, 20 years, mandated by federal and provincial governments, electricity becomes an affordability issue. Another reason to swap over to cost-effective clean energy is that your solar panels pair well with an electric vehicle and a heat pump, which eventually is going to be mandated anyways. Last comment. A lot of information today. We're going a little bit over time, but this is our process at Kootenay Solar. My business partner and lead electrician does all the permits and installations. I work on the sales and business development side of things. We've just brought on a new staff, Karina Strauss, to handle the administrative work as we're entering into year 3 and just exploding with the amount of projects we have this year already. We're starting to book into June. We're already filled up the first 3 months. We do a free estimate. You submit a free estimate form on our website. I'm going to throw that through the chat room right now. And we use low flight plane imagery to overlay solar panels on your roof. We can see the roof pitches with the low flight plane imagery, and that'll give you a really good idea of how much solar you can have on your property and how much that will offset your electricity bill. So kootenaysolar.com is the website, and get the free quote. That's the first part. Got about 400 estimates in our pipeline right now. Then what we do is we go back and forth and decide, are you serious about doing an installation this year, or do you have any other bills? You know, are you doing a deck? Are you replacing your furnace? What's your timeline look like? When you're ready to move forward with a solar installation, we come and do a free on-site assessment, and then we do the final designs, but we're about plus or minus 5% with that low flight plane imagery. So it's not much difference from your first proposal to what the final on-site assessment will do. But that on-site assessment, we get up into your attic, take pictures of your trusses, look at where the wiring runs will go, the size of your control panel and how much actual energy we can generate on your roof, and a few other things. And then we give you a final quote. Once you're done with that, whether we need to squeeze it into your budget, we take a 10% permit deposit. That does the permit sets. That'll get structural engineer approval. Our structural engineer signs off and stamps your project because we're adding additional dead weight to a house. You don't need a structural approval if you're doing it in a ground mount. We pull the electrical permit. We do all the net metering applications with the utilities company for you. And then once all of that is completed, then we take a the materials deposit. 60% are materials. Most of that is materials. And then we order your materials and get it shipped into our shop here in Invermere. Once we do a quality check on the materials that nothing's damaged and it's good to go, we have Karina and myself schedule an installation date with you. And then upon the final approvals from the utilities company, the tie-in with the net metering program, and we'll also provide you with an energy monitoring system, which basically from your app and from your phone and your computer, you can see what your panels are producing at any given time in the day and how much electricity you're generating. That comes with the systems. And then we'll provide you monitoring access, and that's when the final bill is sent. So that's our process at Kootenay Solar, is we do as much as possible for serious customers without any payments until you're ready to move forward. And again, that free estimate is the first part of it. So what I'm going to do is just stop the recording, and then I'm going to open it up for 15 minutes of question and answers. So if you want to unmute yourself, just go right ahead.